Welcome back, everyone. In this video, part 4 of our 5-part series on understanding multiplication, we are diving into something called the commutative property. Have you ever noticed that when you multiply numbers, it doesn't matter which order they're in? That's because of the commutative property. Today, we'll explore how it works and why it's so helpful in math. By the end of the video, you'll see how switching numbers around can make solving problems even easier. Let's get started. Now we're going to learn two important math words, factors and product. These words are key to understanding multiplication. Let's start with factors. Factors are the numbers we multiply together. For example, if we have 2 times 3, then 2 and 3 are our factors. They're the numbers we're multiplying. Next, we have the product. The product is just the answer you get when you multiply the factors. So, in 2 times 3 equals 6, the product is 6. Remember, factors are the numbers you multiply, and the product is the answer you get. That's it. Now you're ready to understand multiplication even better. Great job. Okay, math friends, let's learn something cool together. The commutative property in math means that when you're adding or multiplying, you can switch the order of the numbers and you still get the same answer. Let's try it with multiplication. If we multiply 2 times 4, we get 8. Now let's flip the order to do 4 times 2. What do we get? 8 again. See, even though we changed the order, the answer stayed the same. That's the magic of the commutative property. Let's talk about something called an unknown factor and how we can use the commutative property of multiplication to find it. Take a look at this problem. 7 times 9 equals 9 times something. We have a missing factor, 9 times something. How can we figure out what the missing factor is? Since we know that 7 times 9 and 9 times 7 both equal the same product because of that commutative property, we can see that the missing factor has to be 7, and they both equal 63. So switching the order in multiplication helps us solve for the missing number. Pretty cool, right? Alright everyone, let's give it a try with a fun problem. We're going to look at 2 game boards and figure out how many squares each one has. First, let's look at Kim's game board. She has 3 rows with 2 squares in each row. To find the total number of squares, we can multiply 3 times 2. What do we get? That's right, 3 times 2 equals 6. So Kim's game board has 6 squares. Now let's look at Jim's game board. He has 2 rows with 3 squares in each row. To find the total here, we can multiply 2 times 3. What do we get this time? Exactly! 2 times 3 equals 6. So Jim's game board also has 6 squares. So both Kim and Jim have 6 squares on their game boards, even though their rows and columns are different. Alright everyone, let's practice matching arrays to the correct equations. We have 2 equations. 4 times 3 equals 12 and 3 times 4 equals 12. Both give us the same product, but they look a little different. Let's see how we can tell them apart by looking at the arrays. First, let's look at 4 times 3 equals 12. This means we have 4 rows of 3. So we can draw an arrow to the array with 4 rows and 3 squares per row. Now, let's look at 3 times 4 equals 12. This time, we have 3 rows with 4 squares in each row. Let's use an arrow to make that match. So remember, the first factor in a multiplication equation tells us the number of rows, and the second factor tells us how many squares are in each row. Both arrays give us 12 squares total, but they're arranged differently. Great job, math stars! You learned how to solve multiplication problems using the commutative property and did an awesome job. Before you go, don't forget to like, share, and follow for more fun math adventures. Thanks for watching, and remember, math is not just fun, it's magic. Keep practicing and this will be a breeze, and we'll see you in the next video.